Okay, NPR, NCR algebra. So let's propose that NC2 is equal to 10. Well, first of all, I'm going to write the NCR formula. NCR equals n factorial over n minus r factorial with another r factorial on the bottom. And I'm going to propose the question. NC2 equals from the above. Now it's equal to 10, but I'm going to substitute into the formula first, which would be n factorial following the formula over n minus 2 factorial with another 2 factorial on the bottom. And I'm going to remember from earlier in factorials, back in 11.2, we learned that we can expand the bigger one. So n factorial is the bigger one, so I'm going to expand it. n times n minus 1 times n minus 2, and then I'm going to close the factorial because I have an n minus 2 factorial on the bottom, which means I have a 2 factorial still on the bottom. And I can cross off the n factorial from the top and the bottom. Now, they originally said this was equal to 10. So now I'm going to substitute 10 in for NC2 on the left-hand side. I did it on the right-hand side in the notes, but whatever. NC2 is equal to 10, so I substitute 10 in for NC2. And I'm going to clean it up. So I have 10 equals n times n minus 1 over 2 factorial. Now 2 factorial is just 2 times 1, which is just 2, and I'm going to times both sides by 2. So I'm going to simplify that. 20 equals n open bracket n minus 1. Now I can distribute n squared minus n, and I can get it equal to 0. And then I can, so I subtracted 20 from both sides to get it equal to 0. Then I can factor it. N minus 5, n plus 4. Feel free to go back to grade 10 and learn how to factor those things. So if I set my brackets equal to 0, n is equal to 5, and n is equal to negative 4. Now I can't choose from a negative number of objects, so n is just equal to 5. Another example, seen off to the right, NP2 is equal to 42. So I'm going to write the formula. NPR equals n factorial over n minus r factorial. And I can substitute in. So the given information is NP2 equals, and I can substitute into the formula, so that's n factorial over n minus 2 factorial. And then on the right-hand side, I can expand the bigger one, the top, which is going to be n times n minus 1 times n minus 2. And remember, I can close the factorial anytime I want because I have an n minus 2 factorial, which means I can cross those off from the top and the bottom. And on the left-hand side from the given information, I know NP2 is 42, so I'm going to substitute 42 in for the left-hand side NP2 because they're equal to each other. So then I can clean it up. 42 is equal to n open bracket n minus 1. I can distribute, therefore 42 is equal to n squared minus n. I can get it equal to 0 by subtracting 42 from both sides, n squared minus n minus 42, and I can factor it. 0 equals n minus 7, n plus 6, which means if I set those equal to 0, I get n equals 7 and n equals negative 6. I can reject negative 6, and n is equal to 7. I can also check my answer. 7p2 is equal to 42, check mark. Substituting my answer back into the original to make sure that it works. You can also just check guess and check. 5p2, 6p2, 7p2. Oh, that's 42. Perfect. 7. So great way to check your answer. Okay, same page, bottom left. NC3 equals 4. I'm going to clean that up a bit. NC3 equals 4. Well, again, I'm going to write the formula for n. NPR equals n factorial over n minus r factorial with another r factorial on the bottom, which is, NC. I'm going to erase the left-hand side of the formula and rewrite it, NC. And that is the correct formula. So now I'm going to substitute in. So we get n factorial over n minus 3 factorial times 3 factorial. And on the left-hand side, NC3 is 4, so I'm going to substitute 4 in on the left-hand side. And then I can expand it. So 4 equals, and I can expand the bigger one, which is the top, which is n times n minus 2, times n minus 1, times n minus 2, times n minus 3, and then I can close the factorial because I have an n minus 3 factorial on the bottom. I can cross off the n minus 3 factorial from the bottom, top and the bottom, and I'm left with 4 equals n open bracket n minus 1, n minus 2, and I still have a 3 factorial on the bottom, which is 3 times 2 times 1, or 6, and I can times those sides by 6, and I'm left with 24 equals n open bracket n minus 1, n minus 2. Now, as seen in the notes, I've FOILed it all out, and I've got it equal to 0, so I'm just going to skip those steps, which is n cubed plus 3n squared plus 2n minus 24. And this thing should look like a cubic factoring from polynomials earlier in the chapters, whereby we can factor it by doing guess and check and all sorts of methods. But a lot quicker just to try it out. 4c3, etc. from the top. nc3 is equal to 4, so try 4c3, try 5c3, etc. Turns out that 5c3 equals 10, and 4c3 equals 4, therefore n equals 4. Very valid, just doing a guess and check method. Further off to the right is an example where it's impossible to do, and you actually have to only do guess and check. Very valid method. NPR Algebra.